video on playgrounds, I showed you the value history that we could go in and look at items as they'd be displayed. There's also a quick look that when a line is being executed, you can do this quick look. It's like a command line output, but for things like our image view, we can use the quick look and see our red image view or our image. All right, so I've created a new playground. We're going to explore variables, constants, and data types. You'll notice on line 1 here there is a comment. So comments in Swift are much like comments in C#. You can use the 2 slashes for a single line. We can also do a block with a slash asterisk. And end it with an asterisk slash. So everything on those 5 lines is part of this block comment. Okay, so variables are created with the word var. We give our variable some name. And assign it some value. So campus is my variable, and it contains the literal string South Mountain CC. Variable in this case is inferred as far as this data type. Swift is smart enough to figure out this is a string variable because it's being assigned a literal string. If I do var xyz equals 12, it's going to consider this to be an int data type. There are 5 main data types as far as being inferred. I could do var abc equals 3.897, and this is going to be a double data type. There is a bool data type for Boolean values that may be inferred. And then we have a character data type. If it's being assigned a literal string that is 1 character long, that will be a character rather than a string. And the data type is character, it's not char like a lot of other languages. So the word character is spelled out in terms of the data type. So in summary, we have 5 different inferred data types: string, int, double, bool, and character. There are other data types that may be explicitly referenced in terms of creating a variable. I have a variable called tax rate. I'm going to make it a floating point variable, or data type of float. And maybe it's going to be assigned a value of 0.083. The float data type has a precision of a certain number of digits, and so while I assigned 0.083, it actually interpolated out to 0.082999999. Floats are 32-bit. Now, even though data types might be inferred, we can specify them as well. The double is 64-bit. It has a greater number of precision, but I think what's really happening here is float is being converted from the double, which is why we're getting this interpolated number out that's much longer. Should still be accurate in our calculations. There are other integer data types available to us besides just int. There are both signed and unsigned data types for integer. So the signed data types, meaning they have either negative or positive values, would be an int 8, so an 8-bit integer, a 16-bit integer, a 32-bit integer, and a 64-bit integer. Now, of course, the more bits, the larger the range of values it can contain. So an int 8 can have a range from, I think it's a minus 127 to a positive 128. There's also unsigned integers, which are uints. And again, there's an 8-bit variety. There's a 16-bit. There's a 32-bit and a uint 64. Now, you might also note that when you have an integer value that is inferred, such as we had up here with XYZ, on a 32-bit system, that will be an int 32, but on a 64-bit system, it will be an int 64. So let's create a variable a that's going to be of type float. I'm going to have it equal 3.15. Var b is going to be a double. And we'll make it 6.25. Now var c, which is also going to be a double, and it's going to equal a plus b. And I get an error on this statement. The reason being, when we're doing math, combining variables that are of different data types is not allowed, except for in a few cases where it can be inferred. In this case, I've got a double and a float being added together, and it won't let me do that. So the way we fix this is I convert a to a double, and to do that, I call the double class constructor, pass it a, and that will convert this to an a value. Now, it's not changing a from a float to a double, it's simply changing the value here to a double. A remains a float variable. But now I'm getting a value here. Now, we expect 9.40. Notice it's also interpolated out here through the calculation because of the value that was assigned to our variable a. The same thing is going to be true with string and char. So we had campus up here in terms of a literal string or string variable. In widening conversions, Swift will do some of those automatically for us. So we can say campus, we could increment it with a space, and then maybe the value of my char. And you'll notice I get a value of South Mountain CCA. So it converted the char or appended it into our string. Sometimes it would seem like the conversion factor should be taken care of for us. Let's do var d as an 8-bit integer. I'll have it equal 32. I'm going to do var e as an unsigned integer, 8-bit, have it equal 24. And then let's do var f equals d plus e. And you notice I'm getting an error here. And the error is it cannot invoke the addition operation with an argument list of type int 8 and uint 8. So even here, even though we should be able to add 32 and 24, it doesn't allow us. Okay, so what would happen if we try to type f maybe as integer 8? So it still doesn't like this. Still getting error. What I need to do is convert e to an int 8. and now that's fine. So you would think even though the 24 and 32 sum fits within the range of an int 8 that would do it for us automatically, we still have to explicitly do typecasting. So just a little gotcha to be aware of in Swift. It's pretty strict in terms of its typecasting.